Okay, these are the practice problems on 184 to 185. Some of them are pretty quick. Let's start with number 10. A stunt bicycle rider goes 39 minutes in 3 seconds. How fast is a cyclist riding? Since we weren't given any direction, then we're going to look at the scalar version of how fast, which is speed. So speed we know is distance divided by time. The distance in this case is we went 39 meters, and we did that in 30 seconds. So 39 meters divided by 30 seconds. And that equals 1.3 meters per second. Number 11, a skier goes 148 meters west in 5.5 seconds. What's the skier's velocity? So velocity is the displacement divided by the time. The displacement is given to us, 148 meters west. That's a negative 148 meters divided by the time of 5.50 seconds. That would be a negative 26.909 meters per second. As a final answer, the negative means we're going west, and if we're looking at our significant digits, there's 1, 2, 3 significant digits in each of our data points. Our final answer then should have 1, 2, 3 significant digits. Our final answer should be 26.9 meters per second towards the west. So for number 12, a jet plane travels 1,358 kilometers in a time of 2 hours and 45 minutes. We want to determine the speed, which is great. I mean, that's just distance over time, right? Where the distance is 1,358 kilometers. And the time is 2 hours and 45 minutes, or 2 3/4 of an hour, 2.75 hours. But we don't want our answer in kilometers per hour. We're asked, we're asked to have the answer in meters per second. So we're going to have to convert kilometers to meters and hours into seconds. We can do that by multiplying by conversion factors, right? There are 1,000 meters in 1 kilometer, and we know that there are 3,600 seconds in 1 hour. We can also do the reverse. We can say there's 1 kilometer in every 1,000 meters, or there is 1 hour for every 3,600 seconds. We're going to multiply by those conversion factors. We'll have to pick the correct ones in order to get us the units we want, which is meters per second. So again, what we want to end up with is that speed in meters per second. So meters on the top, seconds on the bottom. So what I'm going to do is I'm going to select the conversion factor that has the unit I want where I want it. What I mean is, if I want meters on the top line, then I'm going to choose the conversion factor that has meters on the top line. I'm not going to choose the bottom because meters is on the bottom. I want meters on the top, so I'm going to multiply this by 1,000 meters for every 1 kilometer. Similarly, I want meters per second. Seconds should be on the bottom line. So when I'm converting my hours and seconds, I won't multiply by that conversion factor. I'm going to multiply by this one because it has seconds on the bottom line, just where I want it. Okay, so I'm going to multiply by 1 hour, having 3,600 seconds. Okay, we do that because we want to end up with meters per second. Notice how you have kilometers on the top line, and it cancels out with kilometers on the bottom line. You have hours on the top line that cancel out with hours on the bottom line. And look at the units you have left. Meters on top, seconds on the bottom, which is exactly what you want to end up with. Okay, that's units. what exactly are we plugging into our calculator? In your calculator, you're taking the 1358 multiplying by 1,000, and then you divide that by 2.75 multiplied by 3,600. So in your calculator, you should be getting 137.17, and that would be in meters per second. Don't forget significant digits for your final answer. 1, 2, 3, 4 sig digs there. 1, 2, 3 sig digs there. So our final answer should have 1, 2, 3 significant digits. Our final answer should be 137 meters per second. Now there's a lot to cover here, right? With formulas, with units, and all these numbers. Significant digits are important, but I wouldn't focus on it right now. Just focus on, are you getting the correct equation? Are you plugging in the correct numbers? Are you plugging it into those numbers into your calculator correctly? And only after you mastered that, start worrying about significant digits more. Okay, so don't worry about them too much. Just keep them in mind though. On to number 13. A cheetah runs at a velocity of 29 meters per second. If it runs for 8.4 seconds, what's its displacement? Okay, so we want to figure out what the displacement is. We're given velocity and time, and we have an equation that relates all those three. Velocity equals displacement divided by time. Now you might be tempted to plug in numbers here right away, but I think the best way to proceed is to manipulate the equation for the variable you want and then substitute the numbers in. Okay, so what we want to get at is the displacement. So we want to figure out a way to get displacement by itself. Right now it's being divided by delta t. So to get rid of that divide by delta t, we'll do the opposite, which is multiply by delta t. And if we do that on one side of the equation, we must do that on the other side of the equation for things to balance out. Okay, so we started out with v equals d over t. Then after we multiplied by t, on the left side we have velocity times time. And on the right side, the t on top and t on the bottom cancel out, and you're left with displacement by itself, which is exactly what you want. Okay, so now you have an equation for displacement, which is v times t, or velocity times time. We can plug in our numbers. We're given a velocity of 29 meters per second, and we're given a time value of 8.4 seconds. So we're multiplying those two together. If you notice your units, seconds on top cancel out with seconds on the bottom, and you're left with a unit of meters. Okay, which is correct, because you want to figure out what displacement is. Displacement's given in meters. So we'll just plug in 29.8 times 8.4 in the calculator. That gives us 243.6 meters for displacement. That's a positive number, so we're going in the positive direction. We're going north. Let's take a look at significant digits. Our original, or our data, has 29, which is 2 sig digs, 8.4, which is 2 sig digs. So our final answer should have only 2 significant digits. How can we write that number using only 2 significant digits? We can use scientific notation. 2.4 times 10 to the power of 1, 2 is how many times I move the decimal place. So 2.4 times 10 to the power of 2 meters towards the north. Okay, now a lot going on with the final answer. As long as you get to this point right now, 243.6, then you're on a really good pace. You were able to rearrange the equation, substitute the numbers, and plug them into your calculator correctly to come up with an answer. So that's a good thing, you know. But when you've mastered that, get used to looking out for significant digits and units and direction, and being able to write the answer in the correct scientific notation if necessary. So again, if you're at this point, that's great. What you want to do is be able to get to that point. For number 14 here, we're driving to our grandparents' home, which is 95 kilometers away, and we drive at an average speed of 85 kilometers an hour. How long will it take us to get there? So how long is time? So how can we relate speed and distance and time? We have a formula for that. V equals D divided by T. Okay, so we'll start with that formula. We want to get to the bottom line here. We want to get to time. The first thing you have to do is get time back on top. And you do that by multiplying both sides by time. And I should be proper. This is delta D, delta T. So I'll multiply by delta T on both sides. As a result, on the right side, we'll have V multiplied by delta T. On the right-hand side, we will have delta T by itself. And then our goal, remember, is get time by itself. So then we would divide both sides by V. We'll see that on the left side, the V on top and bottom cancel out. You're left with delta T equals delta D divided by V. And that's the formula you can use for your answer. The distance we're traveling is 95 kilometers away. The speed we're traveling at is 85 kilometers per hour. Now, the standard units for time and speed and distance are meters and meters per second and seconds, etc. But we don't have to convert anything here, right? We're given a distance in kilometers and a speed in kilometers an hour. So those kilometers, notice, kilometers divided by kilometers cancel out. And your time is going to be the units that's left there. Whatever you calculate, you're going to have time in hours. Okay, so 95 divided by 85 equals 1.1176, and that would be hours. Now we just need to take a note of significant digits. 95 has 2 significant digits. 85 has 2 significant digits. So our final answer should have 2 significant digits. Our final answer should be 1.1 hours. Let's look at number 15. We have a 100-meter track. So a track that goes from 0 meters all the way to 100 meters. When a sprinter leaves the starting line, timers are started. The sprinter passes the 12 meters east line at 1.8 seconds and passes the 56 kilometers east. Whoops. Let's put that here. 56 kilometers or meters east at 6.7 seconds. And just to keep this to scale a little bit, let's move 12 meters east closer to the front. Okay, so that's your diagram. The sprinter is traveling this way. And we want to figure out the velocity between those two positions. Okay, so velocity, which we know is displacement divided by time. But if we want the velocity between 2 points, then we should flesh out that equation and say the velocity is the displacement, as in the second position minus the first position. And the time would be time number 2 minus time number 1. And with that equation, we just fill in the values. D2, or position number 2, is 56 meters to the east, minus D1, or position 1, which is 12 meters to the east, divided by time 2, which is 6.7 seconds, minus time 1, which is 1.8 seconds. 56 minus 12 is 44, that's meters. 6.7 minus 1.8 is 4.9 seconds. 44 divided by 49 is 8.97959, etc. meters per second. If we're looking at significant digits, there are 2 significant digits in each of those numbers, in each of our data points. So our final answer should have 2 significant digits. Our final answer then should be 9.0 meters per second. Okay, so number 16 is more of a standard of excellence kind of question. So don't worry about it if this one is a bit more difficult. Basically, you have fence posts in a pasture that are 2.5 meters apart. And you have a horse that's going to run along the pasture. And after the horse, if this is the first fence post, after the horse passes the 5th one, so 1, 2, 3, 4, 5, after the 5th fence post, and the horse is galloping, the horse does that in 9 seconds. Okay? Or the time on your stopwatch is at 9 seconds. By the time the horse gets to the 14th fence post, the second hand is on 11.5 seconds. So that's 6, 7, 8, 9, 10, 11, 12, 13, 14. So at fence post number 14, the time is 11.5 seconds. So the horse passes the 5th fence post, you hit 9 seconds. The horse passes the 14th fence post, your timer is at 11.5 seconds. What's the horse's velocity? Well, we have a formula for that. Velocity equals displacement divided by time. If we're looking at the velocity between 2 points, we can flesh this out and say it's position, or your final position. We'll say that's position number 14 there, or the position at the 14th fence post, minus the position, your first position, or your initial position, which is the position at the 5th fence post. And we'll to get the time interval, we'll say the time at the 14th fence post minus the time at the 5th fence post. Okay? Now, on the bottom line, you can do it with time. The time at the 14th fence post was 11.5 seconds. The time at the 5th fence post was 9.0 seconds. But what about the positions? Well, remember, it said that the fence posts are 2.5 meters apart. So this is 2.5 meters, 2.5 meters, 2.5 meters, 2.5 meters. From the first fence post to the 5th fence post, you're going 2.5 meters 4 times, right? This is 4 times 2.5 meters. From the first fence post to the 5th one. You can consider that 4 as in 5 fence posts minus the first fence post, right? So 4 times 2.5 equals 10. So you can say that this position is a position of 10 meters. Okay, so your position at the 5th fence post is 10 meters. Similarly then, the position at the 14th fence post is going to be not 14 times 2.5, but 14 minus 1 times 2.5, or 13 times 2.5. So that equals 32.5 meters. So the position at the 14th fence post was 32.5 meters away from your starting point, or from your first fence post, minus the position at the 5th fence post, which was 10 meters. Just for consistency, I'll write it over here. The distance, or the position at the 5th fence post, was 5.5 minus 1 times 2.5, which is 4 times 2.5, which is 10 meters. Okay, so we have all the numbers we need for our velocity. 32.5 minus 10 is 22.5. meters. 11.5 minus 9 is 2.5 seconds. So our velocity then is 9.5 meters per second. We're not told if the horse is moving left or right or east or west. It's just it was moving in a positive direction. We have a positive number. We can just say this is positive 9.5 meters per second. And if we look at our significant digits, those are correct because we have two significant digits at the 10 meter mark and the 9.0 seconds mark. So our final answer should have the two significant digits as well. So again, that was more of a complicated question. Consider that something if you were in Science 10 honors that you would be expected to do. Okay, last example that I'm going to do, number 17. On some highways, exit signs are numbered according to the number of kilometers the exit is from the place where the highway originated. If you are driving south and pass exit 35 at 2:15, then you pass exit 116 at 3:09, what is your velocity? So it's saying, again, those exit signs, the number on those exit signs is numbers of kilometers from the place where the highway originated, or number of kilometers from the starting point. So exit 35 means at a position of 35 kilometers, or at a position at that exit is 35 kilometers. And the position at exit 116 is a position of 116 kilometers away. The time at exit 35 is 2:15 p.m. and the time at exit 116 is 3:09 p.m. If we're asked for our velocity, displacement divided by time, then we take our position, our second position, or final position at exit 116, subtract from that our initial position, which is at exit number 35, divided by the time at exit 116 minus the time at exit 35. Okay, so that's 116 kilometers minus 35 kilometers divided by 3:09 p.m. minus 2:15 p.m. Okay, so on the top line you have 116 minus 35, which is 81. And on the bottom line, you have 3:09 p.m. minus 2:15 p.m. So if you think about it, you know from 2:15 to 3 o'clock is 45 minutes, but you're going all the way to 3:09, so an additional 9 minutes, right? So 45 minutes plus an additional 9 minutes would be 54 minutes. So you have 81 kilometers in 54 minutes. 81 divided by 54 equals 1.5 kilometers per minute. Now, we're not asked for kilometers per hour, but that's just a natural unit for speed if we're talking about highways. So let's convert kilometers per minute to kilometers per hour. Well, what do we know about minutes and hours? We know there are 60 minutes in every hour, or 1 hour has 60 minutes. So if I want to multiply by some kind of conversion factor in order to get my units into kilometers per hour, I want to select the conversion factor that has hours on the bottom line, which is this conversion factor right here. Hours are on the bottom line. Okay, so we're going to multiply 1.5 kilometers per minute by 60 minutes per hour. What that does is minutes on top and on the bottom cancel out, and you're left with kilometers per hour. So 1.5 times 60 equals 90 kilometers an hour, and that is your final answer. This I'd say also wasn't so straightforward because of how you were dealing with time. I wouldn't really expect you to do something like that on a test, so let's again consider this to be a kind of standard of excellence type of question. So make sure, I hope that kind of helped. If it didn't, please join the tutorials online or just ask me questions via email. Please do the remaining questions on page 185. That'll be numbers 18 to 22. Okay, thank you.